There is a place in the desert where man-made monoliths silently stand guard over a gigantic outdoor laboratory. A place where the art of pioneering is still practiced. Where the accomplishments of the past are so close you can reach out and touch them.
There's a missile test today. The block will last approximately another 30 minutes.
Where dreams make their way from the drawing board to reality. It is White Sands Missile Range, the birthplace of America's missile and space activity.
White Sands Missile Range is in south-central New Mexico, filling much of the Tularosa Basin. It occupies an area roughly 40 miles wide east to west and 100 miles long north to south. It's bounded by the San Andreas, Oscura, Oregon, and Sacramento mountain ranges. Headquarters for the 2-million-acre test facility is in the southwest corner of the sprawling range, situated between the cities of Las Cruces and Alamogordo, New Mexico, and El Paso, Texas. The missile range takes its name from White Sands National Monument, which is contained within its boundaries. Managed by the National Park Service, the monument holds the world's largest surface deposit of pure white gypsum sands.
But what is White Sands Missile Range? For starters, it is the largest military installation in the United States. Run by the Army, the commanding general also has deputies for Navy and Air Force. This all-overland national test range has a workforce of almost 10,000 military, civilian, and contractor employees. White Sands is one of the U.S. Army Test and Evaluation Command installations charged with ensuring Army weapons and equipment meet their performance and safety standards. The mission of White Sands begins with the customer, be it the Department of Defense, another federal agency, or a private company who is ready to find out if the engineers and scientists have built an item which will perform according to design specifications. Between the beginning and end of a test program, missile range employees are involved in every operation connected with the customer and his product. In a nutshell, we shake, rattle, and roll the product, roast it, freeze it, subject it to nuclear radiation, dip it in salt water, and roll it in the mud. We test its paint, bend its frame, and find out what effect its propulsion material has on flora and fauna. In the end, if it's a missile, we fire it, record its performance, and bring back the pieces for autopsy. All test data is consolidated, and the customer receives a full report.
The missile range is intimately tied to the cultural and natural history of southern New Mexico. Ancient Pueblo Indians, then Apache tribes, lived within the current range boundaries. Spanish conquistadors explored the area in the 1500s. Control of the area then passed from Spain to Mexico and finally to the United States. In the mid-1800s, Army outposts such as Fort Bliss, Fort Stanton, and Fort Selden were built in the surrounding area to protect settlers and outlying towns on the new western frontier from Apache Indian attacks. The basin was frequented by such notorious Apache leaders as Geronimo and Vittorio. Skirmishes were fought between Indians and soldiers on what is now the missile range. The promise of open lands and rich mineral veins brought pioneering ranchers and miners into the Tularosa Basin, and the area did not escape the colorful Wild West image. Oliver Lee, Billy the Kid, and Sheriff Pat Garrett lived, fought, and died in the vicinity. More recently, Dr. Robert Goddard conducted his experiments in developing working rockets east of White Sands near Roswell, New Mexico. His pioneering efforts soon led to the international development of rockets used for science and war. Indirectly, the missile range owes its creation to Dr. Goddard, the father of the modern rocket. And on July 9, 1945, White Sands Proving Ground, as it was then known, was established.
1 week later, on July 16th at 5:29 a.m. Mountain War time, the world was ushered into the nuclear age with the detonation of the first atomic bomb on the north end of White Sands near Socorro, New Mexico. The 21-kiloton explosion marked the success of the Manhattan Project and its efforts to produce an atomic bomb. Following the end of World War II, the Army began its rocket development program at White Sands. It all started from a single Army launch complex containing a blockhouse, gantry, several concrete pads, and minor structures. Using captured German rockets, equipment, and scientists, including Dr. Werner von Braun, the range built and launched more than 60 V-2s. Other U.S.-developed rockets and missiles, such as the WAC Corporal and Viking, were successfully tested at White Sands. These vehicles carried the first scientific experiments for studying the upper atmosphere. This work helped develop new technologies which would be used to put a man into space. Early accomplishments include the first successful launch of a large-scale two-stage rocket, the first glimpses of Earth from space, the first use of automatic guidance for a rocket, and the first exposure of plants and animals to the effects of zero gravity and cosmic radiation. From the development of the Tiny Tim booster to testing of the Nike and Redstone programs, White Sands lost no time in exploring and refining this new frontier. During the 50s, 60s, 70s, and 80s, White Sands Missile Range has been and continues to be the site of major technological events. Well over 40,000 missile and rocket firings have occurred since 1945.
Today, the missile range's customers are many and varied. About 100 programs are on range each year. Among the Army programs being tested is the Multiple Launch Rocket System, or MLRS. The MLRS is a free-flight artillery rocket system mounted on a highly mobile tracked vehicle which can fire 12 rockets in less than a minute. Testing continues on the Patriot air defense system. Patriot has the ability to simultaneously acquire, identify, track, and destroy multiple high-threat targets. Another Army program testing on range is the Forward Area Air Defense System, a family of short-range air defense weapons designed to counter the enemy air threat of the 90s. A significant program is the Army Tactical Missile System. The missile is an inertially guided round which carries an anti-personnel and materiel warhead. The Air Force conducts tests on air-launched tactical and air defense missiles, guided weapons, and electro-optical weapons system delivery. One of the systems undergoing continual testing on the range is the Advanced Medium-Range Air-to-Air Missile. Tests also continue on the air-to-air Sidewinder and Sparrow missiles, as well as the air-launched cruise missile and the short-range attack missile. The Air Force is also conducting operational tests of the B-1 bomber. The Naval Ordnance Missile Test Station has been part of the missile range since 1946. The Navy's ongoing programs include testing all versions of the standard surface-to-air missile. The rolling airframe missile is launched to intercept a Vandal target. The Navy's vertical launch system continues its testing with the ASROC, or anti-submarine rocket. In addition to weapon system testing, the Navy provides launch support for upper atmospheric sounding rocket programs. The Terrier Black Brant and Ares carry scientific payloads on short suborbital flights to gather solar or stellar data, or to conduct experiments for organizations such as the Strategic Defense Initiative. Support has been provided for commercial rocket launches using missile range assets. Another range customer, the Defense Nuclear Agency, has sponsored nuclear weapon effects simulation tests using large amounts of ammonium nitrate and fuel oil. The information gathered from such tests is used to evaluate the survivability of weapons and equipment to the severe shock and heat effects of a simulated nuclear explosion. During the Misty Picture test, 4,800 tons of ANFO in a hemispheric container were detonated to simulate the air blast and ground shock of an 8-kiloton nuclear device. 100 experiments from the Department of Defense, other government agencies, and some foreign governments were placed on the test bed. NASA's Space Shuttle program is a missile range customer. The White Sands Space Harbor, which is maintained by NASA and supported by the range, is an alternate and emergency landing site for the shuttle. The landing strip was used during the third shuttle mission when Columbia landed at the site on March 30th, 1982. Today, the Space Harbor provides valuable training for shuttle pilots as they fly practice approaches and simulated landings in a shuttle training aircraft.
The reason these programs use White Sands is the excellent service they receive on the missile range. The range is a unique combination of geography, weather, laboratories, personnel, and sophisticated instrumentation, which make it perfect for modern testing. The types and numbers of tests available to range users are almost limitless. Test programs are individually designed to meet all the user's requirements. About 90% of the Earth's existing environments can be simulated on range. Everything from ice and sleet, to tropical heat and humidity, to electromagnetic and nuclear radiation. The missile footage in this video was taken using range optical tracking systems. Additional data is collected from tests using state-of-the-art radar and telemetry systems. Much of this instrumentation is developed at the missile range to meet the specific needs of different customers. Sophisticated computers, using specially designed software, process data from the field and display it in real time for range controllers, safety officers, and users. The computers continually make impact predictions during missile flights to ensure the missile stays within the range boundaries. Commands are sent to instruments in the field, automatically pointing them to acquire the missile for tracking. Other resources include logistics and engineering support, launching, recovery, data collection, airspace, communications support, and security, to mention a few. With more than 50 range directorates and guest tenant activities, virtually every conceivable service necessary for a tester is available at White Sands Missile Range. Many of these organizations have missions which go beyond supporting testing at White Sands. For instance, the Atmospheric Sciences Laboratory is engaged in pure scientific research in studying the atmosphere. It also supports weather forecasting for range missions. Laser testing is provided by the High Energy Laser Systems Test Facility. The facility has several large lasers which are used in vulnerability testing and a vacuum chamber capable of simulating an altitude of 60 miles. The Vulnerability Assessment Laboratory provides test support and research in the field of electronic countermeasures. The U.S. Army's Training and Doctrine Command's Analysis Command at White Sands is known for its use of advanced computer modeling to simulate battle conditions and measure the effectiveness of new and improved weapon systems. Besides NASA's Space Shuttle program, the agency also has a permanent facility on range called the Johnson Space Center White Sands Test Facility. Located on the west side of the range, it is responsible for testing small rocket engines such as those used to maneuver the shuttle in orbit. The facility also houses laboratories engaged in testing and evaluating the compatibility of various materials in a space environment. NASA's Goddard Space Flight Center operates the main and backup tracking and data relay satellite system ground station at the NASA White Sands facility. The ground station receives tracking and data relay information from spacecraft, such as the shuttle, in low Earth orbit. The Air Force Space Command's ground-based electro-optical deep space surveillance system is at the north end of the missile range. Operating at night, this facility is one of 5 sites worldwide designed to keep track of man-made orbiting objects, particularly those in deep space.
In addition to its military and scientific endeavors, the missile range is concerned with protecting the environment. Because White Sands has restricted access, it serves to protect cultural resources and act as a refuge for wildlife. A number of archaeological sites have been found, and it's believed there could be hundreds more. Because of the limited access, these sites will remain untouched for future archaeologists to study. One site shows the raised footprints of prehistoric creatures like woolly mammoths and camels that roamed the basin some 8,000 to 13,000 years ago. Exotic animals such as the African oryx can be found on the 3,200 square mile range. These beautiful antelope were brought to the range in 1969 by the New Mexico Game and Fish Department as part of an exotic animal introduction program. There are between 600 and 800 oryx now on White Sands. Although the missile range has very little surface water, there is enough in a few salty springs to support the endangered White Sands pupfish. These small creatures are the only fish which can survive in the warm saline water found on the floor of the Tularosa Basin. Other animals found on the range include feral horses, mountain lions, desert bighorn sheep, golden eagles, and rattlesnakes. Safety is as important to White Sands as the environment. National Range flight safety personnel assist all customers during test planning and participate during testing to ensure the safety of not only range personnel and facilities, but also that of the surrounding areas. Since the 1960s, the range has contracted with ranchers and landowners on the north and west sides of White Sands so they can be evacuated a few times each year to give safety officials a buffer zone for certain firings. These areas permit testing of some of today's longer-range missiles. An agreement with the state of New Mexico allows short safety roadblocks to be set on U.S. Highway 70 during certain firings. The highway passes just north of the range's main launch complexes, and occasional malfunctions can spread debris on the roadway. Because of these safety measures, the missile range has a perfect safety record with the motoring public for well over 45 years of rocket and missile testing.
This is a glimpse of White Sands Missile Range. Its resources comprise some of the most up-to-date instrumentation and test facilities in existence. But more importantly, the missile range boasts one of the most highly skilled and dedicated workforces in the country. The White Sands Missile Range workforce takes pride in past accomplishments, but more importantly, relishes the future challenges of new and exciting programs. The silent man-made guards are part of the range's heritage as the birthplace of America's missile and space activity. They will watch as White Sands Missile Range continues to pioneer technology which ensures future peace.